Hello everyone, good afternoon. Dear authors and invited guests, welcome to the technical session 6F. Myself Tanish Virmani and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all for the 10th International Conference on Information and Communication Technology for Competitive Strategies ICTCS. Jaipur. The 10th edition of this conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, and the virtual event is being held through Zoom today and tomorrow, which is 16th and 17th December. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we will have 10 presentations. Each presenter will be given 10 minutes for the presenter and 2 minutes for question and answer. After 9 minutes, I will raise a gentle reminder for the same. There is another request to all participants to please stay connected with us till the closing remarks. If you have any queries or update, then you can write me to the chat box. Just before we start the session, I would like to introduce you to the chair for this session. The chair for this session is Dr. Sachin Kumar Gupta. He is an associate professor at Central University of Jammu. With 10 years of academic experience, his research interests include UAV drone communication, cryptography, and network security. Wireless networking, managed intelligent transport systems are all his hobbies. IoT and software designing networks is his specialties. He is committed to advancing research in secure and intelligent communication technologies. Now, I would like to start with the paper. We would be starting with Lydia Princess for the paper title, A Framework for Effective Augmented Reality Integration in STEM Education, Design Principles and Validation.
Hello, all. Good afternoon. I'm Lydia Princess. Before that, I would like to say thanks for this opportunity to present in your conference ICTCS 2025. So, I'm Lydia Princess. I'm from the University of Karunya, Coimbatore, pursuing my BTech here in Computer Science and Engineering with AIML. I'm currently doing my fourth year. Give me a
Yes, you may start your screen share.
yeah. So, is the screen visible?
Yes, it's visible.
So my paper conference topic is about AR, that is augmented reality in STEM education. I have proposed a five design validation that can be used in STEM education, which is in the present trend. So STEM education is basically consists of science, technology, engineering, and mathematics. As this covers the major education purpose, I have proposed a small design principle on this STEM education which can be benefited for a huge variety of people, covering most of the people and the students. So, so the major problem statement regarding AR up to date is that it has a massive potential, but whereas it lacks, it is limited to certain constraints, and it can only be up to date. It is only being variety widespread in games and environment wise, but it can also be used in education, but it actually lacks interactive and concrete concepts. So the core problem is that it's lacks of simplicity and it lacks the applicational purpose of education. It is periodically weak, which means it is interactive, it is visually appealing, but it lacks interactiveness and as well as the effective of learning. The major outcome is not being produced by AI up to date. So there's a small framework that which it is ensuring the contextual alignment. So it focuses on only visual and learning outcomes is not being there, and there is a huge cognitive load work and poor pace usability is being seen in AR up to date. So the major objective that I have done is I have analyzed existing AR and STEM literature from the years of 2010 and then till 2024. I've checked their success factors and I have synthesized a small practical design framework which has five core principles. which I'll be telling you shortly. And then I've validated the framework with certain experts, a number of 30. And then I've proposed a conceptual prototype, which this framework can be used in application, and then certain future research directions as well. So these are the five principal framework that up to date AR have been lacking. They either focus on visual and then don't focus on interactivity, but at the same time they do interactive and then not being visually appealing as well. So these five all put together can bring up a good AR education in STEM education. So we have the first is the authenticative contextual alignment, which means there is a huge gap between AR and a physical environment. Anything being studied should be connected with the physical environment. There should be a touch of physical environment. So there's not much proper alignment still now. So the first principle I would like to propose is that it should be having a physical learning environment as well. And then the second is the dynamic interactivity, which means there should be proper user inputs, and that as well as the apt output should be shown. And then we have a feedback system also, multisensory feedback in the sense any input in form of a voice or in small gestures of hands and the tapping as such can be as such should be easily being captured, as well as there should be a good feedback system. Coming to the cognitive load management is that the AI should not be so much complicated, but should have small, clean visuals, initiative gestures as well. Then the visual stability, it means that the frame rate should be high with less load latency, which means for the input there should be apt and fast output as well with correct frame rate, that is more than 30 FPS the frame rate per second. And the most important is that it should be curriculum based, which means anything that can be learned in AR should have the curriculum being aligned with it, with the learning management system integration capabilities, which means an LMS is a platform where it can be used to track what exactly is being taught, or it is a tracker. Any teacher can have access to it. So this is the expert validation being done for each principle that I mentioned here. Where the five is being done with the clarity as well as the importance. This is the mean rates of is being calculated. Coming to the conceptual prototype. So we are taking, for example, a chemistry lab design. And then we're studying each and every principles, how is it being implemented in here. So the first point is its contextual alignment, the first principle. So, excuse me. The first point is that it's contextual alignment, which means we're taking, for example, a molecule which is being shown in our textbook. We're actually comparing the 2D diagram with the 3D diagram, and that able to be manipulative is what is called as contextual alignment. By the meaning of dynamic interactivity is that students can make use of the particles being shown in the air. They can either drag or pinch, or on pitching how many particles it is going, on tapping the particles chemical properties like its electronegativity, the periodic number, and the periodic table is being shown. So this is a dynamic interactivity, and the above is contextual alignment. In the third is cognitive load management. It is the user interface being delivered in this phase. P4, that is principle 4, is visual stability with low latency is to be managed with the correct use of visual tracking as well as visual drifts of molecules in and there. We have to ensure that the molecules remains fixed in physical space as well. That is visual stability. And the most important is the curriculum scaffolding. Scaffolding is nothing but how the education is being dragged along, and how we are ensuring that it's going to be helpful in our future as well. So here, the 2D molecule is being predicted, which will be taken as a pre-activity, and it is followed by data logging module, which is going to be, it captures the final molecular confliction, and that is going to be called as a success state, which is considered as post activity. So this is the a small conceptual prototype implementation, which is the chemistry AR lab, uh, focusing on the five principles. Coming to the conclusion part, I have split this into three things which research achievement have done. The expected impact, where it can impact the developers, the educators, the students, as well as institutions, as well as the theoretical contribution. Thank you, sir.
Thank you for the presentation. Do we have any questions for us?
Could you please tell me what is the key difference between augmented reality and virtual reality?
Virtual, yes, sir. The basic difference between AR and VR is that AR is also a digital transformation where the particles are being fitted into the real environment. Whereas in the virtual environment, the whole setup is being digitally visualized. The entire environment is being digitally modified. Whereas in augmented reality, only the digital parts are being kept on the physical environment, where we can also have interaction with the real world as well. That is the main difference between an AR and a VR.
So, where is nowadays real-time applications of both this technology?
Definitely, sir. So in VR, we can make use in tourism. And in AR, the main application we can use it is during the medical diagnosis or medical operations for educational purpose also.
Okay. Okay, that's it from my side.
Thank you, sir.
Thank you. Now we'll be moving on to the next presenter. And we have Gopiha S with the paper titled AI for Water Resource Management.
Yes, ma'am. Shall I present the screen?
Yes, you can start sharing your screen.
Am I audible here?
Yes.
Good afternoon to the respected panel members and everyone present here. Today I am presenting my work on artificial intelligence for water resource management. So as we all know, water is one of the most critical natural resources. However, due to population growth, climate change, and urbanization, managing water has become very complex. So water resource management today faces multiple challenges such as water scarcity, pollution, and climate impacts. So, conventional systems rely on fixed routes and manual monitoring, while AI provides a data-driven and adaptive approach. It uses like machine learning, deep learning, fuzzy logic, and hybrid models. So these techniques helps us to forecast the water demand, like also in detecting leaks early, predicting system failures, and also to help us optimize the usage of water. AI also improves water quality monitoring, precision irrigation, and flood forecasting, making water systems more resilient. So, water scarcity and pollution are major global concerns. Many regions already experience seasonal or permanent water shortages. So, traditional water management systems are reactive. They respond only after a problem occurs. AI introduces real-time monitoring and prediction, so that helps us to continuously learn from the historical and live data. So this enables proactive decision making instead of being reacting at the time of the problem. Helps us to act before a crisis happens. The objectives of the works are clearly defined. Firstly, is to explore the various applications of AI in water resource management. And second, the objective is to analyze AI-based techniques for water demand forecasting, lead detection, and proactive maintenance. Third, we identify current, that is the existing challenges, and also suggest future research directions for implement. So these are the so several studies highlights the effectiveness of AI in water management. So for water forecasting, researchers like Adamowski and Sweti used ANN, STM, and LSTM model. These models help us to handle the non-linear patterns and also to provide accurate long-term predictions. So the leak detection studies show that CNN and law enforcement detect faults early. So this helps us to overall AI performs outperforms traditional statistical methods. That is what this paper is all about. And AI techniques are used depending on the Hmm. Also, hybrid models combine multiple techniques for improved performance. So together, these techniques make water systems intelligent and adaptive. Let us look at the different of the ML identifies patterns from historical data. Physiologic is useful when inputs are certain and it's the current trending AI technique, which gives a reason why such models are giving such outputs. So, demand forecasting predicts short term and as well as long term optimization. This helps us to plan supply efficiently and also avoid shortages. So next is the leak detection systems that helps us analyze the flow and pressure data. AI identifies abnormal patterns that indicates the leaks or pipe flows. One of the major that is in- early detection. Early detection also reduces non-revenue water and improves the infrastructure. In water quality monitoring, sorry, in water quality monitoring, water quality is crucial for public health. So AI systems uses IoT and continuously monitor water parameters. This ensures faster response control. So let us look at the AI in agriculture water management, which is crucial, especially it comes to agriculture consumes a large amount of fresh water. But they are by analyzing soil moisture, weather data, and also crop needs. Satellite and crop stress and water deficiency. This enables precision irrigation. So the result is reduced water wastage, improved crop yield, and also sustainable farming. So let us look at the challenges and limitations. Despite its benefits, AI adaptation faces quite few challenges. That is the first major thing is data when it comes to AI. So data quality and sensor interoperability are major issues. High implementation costs limit in developing languages. And also there is a lack of digital literacy and skilled professionals. So strong collaboration between academia and the government is solutions. We'll just look at few case studies. In Barcelona, air with the help of AI, water losses was reduced by nearly 20%. And in Singapore, creative AI improved urban water operations. And in Europe, machine learning enhanced wastewater monitoring. So these are the examples that proves the AI's practical effectiveness. Let us look at what are the futuristic directions that the AI is moving towards. So, federated learning enables privacy-preserving model training, and edge AI allows real-time decisions at sensor level. And also, integration with climate models helps us to improve the drought and flood prediction. And explainable AI, as I said earlier, increases the transparency and trust in AI system. AI is becoming a key pillar in modern water management. It is essential and efficient for sustainable water management. So, although the challenges exist, we should overcome these challenges by improving the data quality and including the necessary cost that is required, and also spreading awareness of the digital literacy. New technologies like Edge AI, federated learning, and smart sensor networks offer more adaptive solutions. So, it is, AI will definitely play a key role in ensuring safety, equity, and sustainability for future generations.
Sir, do you have any questions for a presenter? Thank you for your presentation. We'll call the next one. You can stop your screen share. Now the next author I would like to call is Monisha with the paper title Comparative Study of Bio-Inspired Algorithms for Video Anomaly Detection using 3D CNN based deep learning. Ma'am, are you there?
Good afternoon. Good afternoon, everyone.
Ma'am, you can start your screen share.
So my screen is visible.
Yes, now it's visible.
Hi, I'm Monisha from Sri Siva Subramanian Nadar College of Engineering. Today, I will be presenting our paper titled Comparative Study of Bio-Inspired Algorithms for Video Anomaly Detections. So, moving on to introduction. Video surveillance systems generate a huge amount of data, making manual monitoring time consuming and error prone. Hence, automated video anomaly detection has become crucial for public safety and applications. So, 3D CNNs are effective because they capture both spatial and temporal features from videos. However, the performance highly depends on proper hyperparameter tuning. So, we used bio-inspired algorithms. So, traditional hyperparameter tuning methods are insufficient and require manual effort. So we use bio-inspired algorithms offer automated optimization and better convergence. So key problem we addressed here is which bio-inspired algorithm best optimizes 3D CNN for accurate and real-time video anomaly detections. So we move on to gap analysis. Most existing systems rely on manually tuned 3D CNNs. Research mainly focuses on architecture improvements, often ignoring hyperparameter optimizations. There is a limited comparative analysis of bio-inspired algorithms for 3D CNN optimizations. Also, convergence, speed, and computational efficiency are rarely evaluated. So, our work fills these gaps by comparing genetic algorithm, particle spam optimization, and differential evaluations in a systematic manner. So the main objective of our work is first to design a lightweight simple 3D CNN for anomaly detection, and secondly to apply these bio-inspired algorithms for hyperparameter optimization, and finally compare these algorithms using macro F1 score and convergence behavior and training time. So this is the data set we used for our application. So we used the RWF 2000 dataset, which contains 2000 real-world video clips. It consists of two classes, paid and non-paid videos. This data set includes indoor and outdoor scenes with challenges such as oscillations and camera motion, so making it suitable for real-world evaluations. These are the sample videos from the dataset. This is our methodology or proposed solution of our paper. Uh, Methodology starts with pre-processing. The video frames are extracted, resized to 112 into 112 and normalized and converted into 3D sensors. Then we used a simple 3D CNN consisted of 3D convolutions, pooling and fully connected layers, followed by a small, software classifiers. The model is lightweight and suitable for real-time inference. So we optimize two key hyperparameters, learning rate and number of epochs. Three bio-inspired algorithms such as genetic algorithm, particle span optimization, and differential evolutions are used here. Then the main optimization objective is to maximize the macro F1 score by ensuring a stable convergence and reduce your training time. So this is the workflow of our project. This illustrates the overall workflow starting from video input, pre-processing, model training, and bio-inspired optimization, and final evaluation. So these are the screenshots of our experimental results. Show that the bio-inspired optimization significantly improves the performance over the baseline model. Among the three algorithms we used, particle span optimization achieves the best macro F1 score compared to others and converges faster and lower computational cost compared to the genetic algorithm and differential evaluations. So finally, we conclude that we performed a comparative study of genetic algorithm, particle span optimization, and differential evolution for optimizing a simple 3D CNN. In that, particle span optimization consistently outperformed the other algorithms. So the proposed simple 3D CNN plus particle span optimization framework is efficient and lightweight and suitable for real-time CCTV surveillance application. These are the some reference papers, key reference papers we used in our study, and detailed references are available in field paper.
So do you have any questions for our presenter?
Yes. Could you please tell me which bio-inspired optimization algorithm you have used here for the comparison purpose with your proposed techniques?
We used three bio-inspired algorithms, sir. Differential evolution, genetic algorithm, and particle span optimization.
Is there any kind of ACO algorithm for same purpose?
We used
ACO.
uh, but we
Okay.
use these three use only, sir.
Okay. No issue. Okay.
You can stop your screen sharing.
Okay, sir.
Yeah. Now I would like to call the next person. Next author is Ketlego with the paper title Designing a Digital Twin Setup for Augmented Reality, Enhanced Downtime Reduction in Smart Manufacturing.
Good morning, everyone. Can you hear me?
Yes, I'm able to hear you. Okay, please start your screen sharing.
Okay. Can you see my screen? Can you see my screen?
Yeah, we can.
Okay. Good day, everyone.
Visible
My
right
name
now.
is Katlego, and the title of the study is Designing a Digital Twin Setup for Augmented Reality Enhanced Downtime Reduction in Smart Manufacturing. This is the table of contents of the presentation. Introduction. Downtime reduction is critical for operational efficiency. In this study, an experimental setup where a digital twin serves as the baseline system is designed. The key is that the augmented reality can react faster, giving operators an early visual cue, while the digital twin continues running deeper diagnostics in the background. By combining fast human guidance with detailed analysis, the goal is to give operators a head start and reduce unplanned downtime. Smart manufacturing is increasingly described as a human-centric paradigm where digital technologies support rather than replace operators. Yin and co-authors place this shift within Industry 4 and the move towards Industry 5, where digital twins provide system insight and AR serves as the human interface. Industry 4 focused on automation, connectivity, and cyber physical systems. Industry 5 shifts the emphasis. It becomes more human centered, adaptive, and resilient with a stronger focus on sustainability. It highlights collaboration between humans and intelligent systems. This sets the stage for how technologies can complement each other in modern manufacturing. A digital twin is a digital representation of a physical system used for real-time monitoring and fault analysis, as Chabalala and Kuriakos has described. Because the setup is experimental, a digital shadow is used as a proxy for the digital twin, as full bidirectional control is not required at this point. Digital shadows provide snapshots of physical system states, as shown by Tuba and co-authors. Augmented reality, by definition, overlays contextual information onto physical equipment, helping operators quickly interpret faults, as shown by Nair and co-authors. In this work, AR will serve as a fast operator first layer. What is unplanned downtime? Unplanned downtime refers to unexpected production stoppages as defined by Abafi and Adokola. And in the context of a digital twin-enabled water bottling plant at the Central University of Technology in Bloemfontein, Free State, South Africa, as a case study, unplanned downtime typically results from sensor-related faults such as water level management, water flow monitoring, accurate bottle counting, as well as physical bottlenecks on the system. Because the stations are tightly coupled, a single failure can halt the entire production line and significantly reduce throughput. The approach. Prior studies by Perno and Lastrucci show that combining augmented reality with digital twins improves operator understanding. Building on this, the aim of this study is to use AR to provide fast visual context for operators during high-pressure fault situations, while the existing digital twin continues deeper diagnostics processing in the background. Methodology. Above is the simplified architecture used to implement the water bottling plant prototype. 3 dip switches represent the physical sensors, the water flow sensor, the water level sensor, and the bottle count sensor, and their respective states read by an ESP32. This setup forms the digital shadow of the system, where the physical state is mirrored one way to the cloud, as mentioned earlier. The ESP32 sends small HTTP payloads to ThinkSpeak, and Simulink polls this data to render status lights and gauges in real time. This pipeline serves as the baseline, and all latency measurements begin from this point. This table defines the system states used to classify faults in this study. The same rules are applied to both systems to ensure a consistent comparison between DT and AR. Diagnostic tests. This setup includes 6 diagnostic tests, but for time and clarity, this paper focuses on 3 foundational ones. Test 1, latency in visual fault response. Test 2, network interruption sensitivity. And test 3, restart recovery speed. The prototype dashboard is built in Simulink and MATLAB, representing 3 stations in the bottling line. In this example, a fault occurs at the first station, the flow sensor, triggering the downtime indicator shown by the red LED. For test 1, the visual latency is measured by recording the dashboard at 60 frames per second and counting how many frames pass before the display re-renders the updated state. This frame-based method is used because the study is human-centered and will later support analysis of the operator's visual reaction time. Latency is also calculated using timestamp differences for validation across tests. However, for this test, visual perception is the primary metric. 60 frames per second was the highest stable recording rate available and provides sufficient precision for the observed 100 to 200 millisecond refresh changes. In test 1, the visual latency drops from roughly 12 frames to about 5 frames as the system runs. This happens because of caching. First renders are slower, later updates are faster. While this is common, this behavior can increase latency after restarts. As future work, the AR design will bypass the cloud polling stage and render directly from the circuit sensors to support rapid operator feedback, while the deeper processing remains with the digital twin. Preloading CAD models as a feature at startup is expected to reduce the caching latency. Diagnostic test 2 evaluates how the digital twin responds under adverse network conditions. Using a network manipulation tool called Clumsy, 2 network impairments are applied, namely an artificial delay of 600 milliseconds and a 10 kilobyte per second bandwidth throttle. These values represent the conservative worst case conditions that may occur in industrial networks due to congestion, remote connectivity, or restricted links. Latency is measured using timestamp differences between ThinkSpeak and the MATLAB interface. For test 2, under normal network conditions, the digital twin updates with a latency of approximately 8.4 seconds. When a 600 millisecond delay is injected, latency increases to around 14.5 seconds, indicating that the digital twin pipeline is highly sensitive to delay-based network degradation. In contrast, bandwidth throttling has a much smaller impact, with latency remaining close to about 8.5 seconds. This suggests that the system is more sensitive to timing consistency than raw throughput. In future work, an AR-based approach is expected to be less affected by these conditions, since the intended design requires only a single correct visual frame to signal a fault, rather than a continuous cloud polling. Diagnostic test 3. Diagnostic test 3 evaluates the restart recovery speed. It measures how long the system takes to start up and how quickly it renders the first usable diagnostic after a complete restart. Looking at these results, the initial system launch takes roughly 19 seconds, while subsequent restarts stabilize between 11 and 12 seconds. This is mainly due to MATLAB's one-time cloud reconnection and startup overhead. However, the time to render the first diagnostic after launch is short and consistent, remaining well below 1 second across all trials. In future work, the AR application is expected to show similar or slightly improved results. Because the CAD models will be preloaded at startup, and recovery mainly depends on application bootstrapping and internet resynchronization for both systems. This experiment setup applies a shared diagnostic framework to measure latency in both digital twin and the AR system. While a digital twin serves as the baseline of the experiment, it's important to mention that augmented reality and digital twins play different roles. The aim is not to replace one with the other, but to combine their differences as strengths to improve the operator's response and reduce unplanned downtime in smart manufacturing. With respect to total downtime, this study addresses the technical latency aspects first. Once the AR setup and tests are complete, this phase will conclude, and the next phase will focus on the human-centered response and associated latency. I would like to thank the Central University of Technology for supporting this research and the ICTIS India conference organizers for providing this platform to present and discuss our work. Thank you for your attention. I welcome any questions.
Sir, do you have any questions for the presenter? Thank you so much, sir, for presenting. You can stop your screen.
What is the
Yeah,
role of cyber physical system for designing digital twins? Do you have any idea regarding this?
I'm so sorry, sir. Could you please repeat the question?
My question is, do you know about the cyber physical system? So just I am asking for my curiosity, what is the role of cyber physical system for designing digital twins for any applications?
Is the cyber physical system is to make sure that the system can regulate and self-monitor itself.
Okay, okay, no issue. Okay, from my side.
sir, you can stop your screen sharing.
Okay.
Yeah, thank you.
All right.
Yeah. Now we would start with the next author, Ashutosh Kumar, for the paper title Detecting Cross-Site Request Forgery Using Machine Learning and Strengthening IDS/IPS. Yes, sir, you can start your screen sharing.
Okay, let me know if my screen is visible and am audible.
Yes, it's visible and you're audible.
Yeah, perfect. So yeah, Thank you for this opportunity. Good afternoon, respected chairs, reviewers, and all participants. I'm Ashish Kumar from Amrita Vishwavidyapeetham, Coimbatore. Today, I will be presenting my research titled Detecting Cross-Site Request Forgery Using Machine Learning and Strengthening IDS and IPS. So this paper is mainly written by me, and the co-authors are Saurav Srivastav and Sangeeta V. Now, first, wait, I will go to the introduction part. So what is CSRF and what's the impact and why I chose this? So it's you can say it's very critical vulnerability. It was in the OWASP top 10 directly, and it's still in the OWASP top 10 with injection in injection section. So I know this will be a little less covered topic. That's why I chose this. Let me give a small example what CSRF can actually do, or what is it actually. So let's say you are opening a Facebook page in your one tab of the browser, or let's say internet banking in one of your browser, and in another tab you opened a malicious website, which let's say I have designed it, and by that I will make you to send not it's not kind of phishing, like I will send a command in which you should send a request to me, but instead of you should sending a request to me, you will be sending the request to your banking application or to your Facebook account. Let me be very clear, it's this vulnerability is not in the Facebook or any of the internet banking, so we all are safe. But yeah, I'm just giving this example to explain it. So that will send any kind of request to your different tab or different website which is open in your second tab or of any of the tabs. So let's say you are using your internet banking, and let's say you are using SBI or any of the banks, and then I can send you. You will be sending the request to the bank that okay, send Ashutosh 10,000 rupees, and that command will go through you to the your banking application server. So that's the like typical example of what CSRF actually is, and how it works. The same thing you can imagine the Facebook or any of the social medias, that you can I can make you post something, and that will be completely legitimate, and the IP address will be used. The IP address which will be used for sending that request will be yours. That's why it's like very crucial, and it's little, I can say, little difficult that to detect the CSRF. There are a few methods, but yeah, mainly I'm talking about what approach I did and what's my novelty here. I think we are good with the background, and as I told, it's like little difficult, and limitations of traditional systems is there. The limitation is because that will be look completely legitimate request, because that will be originated from the same person who is the actual user. So it's like kind of, we can say, difficult to mean to detect that. And here I'm using the machine learning obviously to deal with this situation. I will cover in the next section how I did this. So yeah, as I told in my previous introduction slide, the problem statement is clear that there is a CSRF challenge, and we need to address it very seriously. There are few measures like implementing CSRF token, and uh, there are a few quite others. But yeah, so uh, I covered this very popular scenario by giving examples like exploiting the authenticated sessions, and there is like failure of rule-based systems, because that will be actually look like the legitimate request, and again there is like lack of integrated model machine learning solutions for this. Now, the motivation, impact, and why it matters. So I think I already took time in the introduction, and I shared that we can do multiple things like the financial frauds, data manipulation, we can affect other key sectors and intelligent real-time defenses there. Like this is our main objective for this. And again, there is a like cloud enterprise because we know we use multiple cloud related things to in our day-to-day life. And let's say if CSRF attacks and in the other tab, or if we are using any of the cloud-based services, then which we most of us uses, then it will be very problematic that any malicious requests can be received by your actual cloud provider or any of your service provider, and they will execute that command by assuming that, okay, hey, it's completely legitimate, because even the IP address will be yours. So the related work and the identified gaps in this section I'll be covering. Okay, it is not like I'm the first person in the whole world to recognize that, okay, this is the CSRF is the actual thing which needs to be addressed. And there are other countermeasures also, but when we check for the machine learning sides or maybe the artificial intelligence side, so there were, you can say, very less papers were there when I was doing my research. And I found that the most closest data set was the match. It was one of the author in one of the papers. So I used his data set. So his data set was basically the headers. So it was 6,000 headers, or we can say 6,000 HTTP requests headers, which he did, which he used, and he created a Firefox extension to detect that. But again, his paper, according to his research, that model was only for the browser end. So it means the only single person can be benefited, or any other person who needs to install that Firefox extension. But yeah, now I wanted to make it a little bit more broader and cover more aspects, and then it was only for the detection of few of the CSRF HTTP headers, but then I expanded it, and then I found that there was a very limited CSRF ML research, and there were again for the IDS IPS, that is the intrusion detection system or intrusion prevention system, is using the AI for other issues, or we can say other of the vulnerabilities, but not for the CSRF actively. So my proposed solution is, as you know, it's clear that it's ML powered CSRF defense. So why I chose ML? Because it was very difficult for, in general, like normal traffic analysis. So mainly we need something that we need is somebody like who is trained on with something and he can identify. So obviously there is no he or she. So that's machine learning who can train on some of the data sets, and then the machine learning can exactly identify with more accuracy. And then again, it's a lightweight also because there is nothing much, as we know that the concept is very clear. So I mainly implemented two concepts. So first one is to take a data set, then train it with the vulnerable and some of the normal HTTP headers, and then do the analysis. And the second part is like integration to the intrusion detection system or prevention system. So yeah,
Excuse
the
me, sir.
method, yeah,
Sir, I just wanted to give a gentle reminder that 9 minutes of the presentation are up.
okay. Oh, sorry. So yeah, the methodology is quite clear that it's the data collection, pre-processing, model training, evaluation, and then its integration. And I will cover like how it works. So I already covered that. Okay, this the feature extraction will be there, ML classifier will be there, and it will be integrated to the IDS IPS, and then as a result, we'll get the secured system. And in my experimental setup, I have used the Python, which is no need more explanation. The data set name is Mitch, and I used the Google Colab. And there is a Snort. Snort is the open source IDS IPS, especially for the network. So that is called NIDS and IPS. And the conclusion is like we get the efficiency has been increased, and the security has been enhanced because it's been real-time integrated with the IDS and IPS. And the future work is like we took one example, so we can take other examples in the WASP top 10, or maybe organizations can use if they think that okay, for the specific vulnerabilities they want to cover it, so they can use this. So yeah, thank you. Any questions are welcomed.
Have you do the comparison between communication cost and computation cost for the same?
Yeah, so the cost will be like here I used only 6,000 HTTP requests, so that was like quite easy. But yeah, in the real time, obviously we can't rely only on the 6,000 HTTP headers, and so there will be like limited scenarios. So I think it would be it would not cost much. I haven't done the exact cost analysis, but yeah, it's not that resource heavy. By this, I can say that it will not be resource hungry or resource expensive.
Okay, done from my side.
Yeah,
Thank you, sir.
thank
You
you.
can stop your presentation.
Yeah, sure. Thank you, everyone.
Now I would like to call the next author, Hemant Dusane, and the paper title is Empowering Strategic Cyber Insurance Decisions: An Integrated People, Process, and Technology Framework. So, do we have you here?
Yes, I got disconnected. Just give me a minute.
Sure, sure.
Uh, can you please share your screen again? Just a minute. I just want to
You can share your screen. It's allowed. The permissions are there.
just give me a minute. Can you see my screen?
Yes, sir. It is visible.
Just go into full screen mode. Is it visible?
Yes, sir.
Great. Good afternoon, everyone. This is Hemant Dusane. Today I'm going to talk about my research topic on the cyber risk insurance. The particular paper is about focusing on the integrated framework of PPT, which is people, process, and technology. Uh, this topic basically is going to help to create a bridge between an insurance company and an insurer who is buying the insurance from the insurance company for the cyber risk. So abstract of this paper is about how the cybersecurity has been evolved in the recent days, especially after COVID. A lot of people have been connected online, started working remotely. The use and reach of internet has been increased. So definitely the attack vectors, cyber surface has increased. Uh, the topic covers the specific ask about how the framework has been designed against the existing framework. So there are currently the recent framework. What I have done the research around is having 8 parameters, how the cyber risk is defined and the insurance is created. So I've added 4 more parameters which are key, important from the industry perspective, and created 12 parameter frameworks. It's more on the in a simple term, I can say it's creating a cyber fitness score of the organization, like where they stand today in terms of cyber fitness. The challenge today in the cyber insurance, as I discussed earlier, is that the world is connected heavily and dependent on the technology and internet, especially on the remote connections. Hence, the cyber threat impact has been increased. There are a lot of caveats when the insurance has been requested or let's say asked to buy, and as well as in the underwriting process. So a lot of form-based information is given by the companies to the insurance company, and that form-based information are very basics like do you have antivirus, do you have firewall, and which doesn't replicate the exact nature or business of the organization. and ultimately it does not reflect the risk what the insurance company is going to take if they issue an insurance to those companies. So the framework what I have defined is around a holistic framework which covers all the aspect of the organization, not just technology, but even people and process. That's why I call it's a PPT based model which integrates 12 parameters based on different factors, including human, process, and technical parameters. The aim of the research was to create a user-friendly decision model because there are a lot of different quantitative and qualitative models used by insurance companies during underwriting and identifying a risk. A lot of time, what happens, they create a risk rating based on the existing data set which is available for the similar kind of industry, but it's not applicable. Give a simple example, for example, there's a biggest private bank in India which has X kind of a risk versus, let's say, a latest technology-based fintech company which started maybe just an NBFC or a banking license has a different kind of risk. So I cannot create an underwriting for a banking domain equal for both the banks or both the companies at the same level. It has to be different. That's where the focus of the research was, and the alignment with the risk exposure. Empowering the strategic leadership. Ultimately, the model is going to help the organization leadership. Normally, in the organization, you will have a chief risk officer and chief information security officer who take decisions based on either proactive or reactive approach. And ultimately, they define the cyber resilience requirement for the organization. So, cyber insurance is one of the parameter which is important for the organization today, which is part of the resilience strategies. Definitely, if you know your own fitness score, you promote the better culture in the organization. So, for example, if I know my height and weight and my blood report, I will definitely take care of myself in a better way. Similarly, if the organization knows the fitness score, they define the better culture in the organization. The objective of research was to identify what are the obstacles for cyber insurance when the insurance is being demanded or provided or supplied. There are key barriers which includes market immaturity, as we discussed. People do not focus on cyber or information risk. They more focus on the business risk. So, translation of a cyber risk to a business risk is important. Inconsistent underwriting, we took multiple examples around it, and decision bottlenecks from the budget and communication gaps. Organizational self protections is around strengthening the protection of the organization through risk appraisal. So, risk is more of a hypothetical event. Normally, in case of cyber, it's always negative. Consider if it is positive, it's not a impactful scenario for the organization, and it has to be aligned towards the cybersecurity standard, which business goals improves the overall resiliency. So, cybersecurity standards, in simple terms, you can say the ISO 27001 standard, or in India, you have a Data Privacy Act. These are certain requirements of the regulatory bodies or industries which demand specific focus on cyber resilience as well. Human factors is very important in risk modeling because even if you have the best technology in the world and the best process in the world, the human are the driving force towards those technology and processes. So their understanding about their behavioral awareness and influence on the overall parameters are important to identify or to create a risk modeling. And then decision support, which enhance the overall tool or technology development in the organization. So if I know my risk better, I can adopt the right kind of a tool to protect my asset. So I can have an antivirus, I can have a SIM-SOAR solution, I can have a DLP, I can have XDR. So based on the requirement, I can buy the solution and then ultimately improvise on my fitness score and ultimately uh, reduce the underwriting risk, and the premium increases the settlement ratio as well. So we have been talking about these three parameters continuously from the slide one. So the focus on each parameters is around like people, you have human vulnerabilities and the awareness around it. How you mitigate this or improvise these factors by giving continuous training, awareness training, expose them towards the HR policies, not limiting towards the taking any actions against them, but how they can improvise their overall day-to-day operations. Again, risk profiling is also important. When we talk about risk profiling means people who are working on the sensitive data or sensitive processes versus people working on the generic data or generic processes. Process pillar is again focus on governance and compliance. So, key components for the process is around how you define the incident management policy or the process, which include incident response. Definitely, if you are a regulated industry, then you need to focus on regulatory standards to implement the processes in the organization. Technology by default is the enabler and has to be there to make sure things are in place so that your people and process function as business as usual you want.
Excuse me, sir. Just
Yes.
to give you a gentle reminder that 9 minutes of the presentation are up.
Perfect. So fitness score we already discussed. This is a framework what I'm proposing with the 12 parameters. Uh, Outcome is more of a dashboard I am presenting, which gives a scoring of. So each parameter has a weightage of maximum of 30. So 12 parameters, more of a 360 higher scoring. So based on the scoring calculation, the organization can understand their fitness score. We discussed existing model has 8 parameters. Mine is 12. Existing covers mostly on technology. This one covers full processes like PPT. Dynamic scoring is included in the model what I have defined. Customization or the flexibility in the model is also defined. These are the future scope and research gaps. So sector specific customization can be possible. We can integrate behavioral analytics in the model. Machine learning is already part of the model, but we can add it for the predictive detection as well. Insurance collaboration and automation. Ultimately, this is going to help the insurance company as well. So that's all I have. If anyone has any question, I can answer.
Sir, do you have any questions for the presenter? Yeah, so we can proceed with the next author. Yeah. The next author we have is Meenakshi Srigandhi. The paper title is Enhanced YOLO V8 with Depth Estimation for Construction Site Safety Monitoring.
Good
Ma'am,
afternoon,
do we
sir.
have you? Yeah.
Can I share the screen?
Yeah, you can start here.
Yeah. Is my screen visible, sir?
Yes, it's visible.
Okay. Yeah, very good afternoon. My paper is entitled with Enhanced YOLO V8 with Depth Estimation for Construction Site Safety Monitoring. So, construction site gather a large amount of construction equipment and workers in a limited space for a short time, leading to potential safety risk at construction site. Detecting the presence of workers, plant, equipment, and objects to improve the safety and productivity is a challenging application for vision-based research. As we know that workers working at construction site is such a critical job, and many illiterate people are employed for this job. Being illiterate, many workers do not follow the safety rules on the construction site. So the main objective of this research is object detection and classification at construction site using deep learning algorithm. And safety monitoring of construction workers at construction site using proximity detection algorithm. So the first, just a minute, sir. One sec. So this is the architecture of the standard YOLO V8 model. The standard YOLO V8 model consists of backbone, neck, and head. The backbone is responsible for extracting rich feature representation from the input image using a series of convolution layers, which captures both the low-level and high-level visual features. The neck then fuses these features at different scales, often using FPN or PAN to enhance the model's ability to detect objects of various sizes and improve contextual understanding. The head then processes the fused features to perform the actual object detection by predicting the bounding boxes, object next scores, and class probabilities. The limitation of standard YOLO V8 is it lacks attention mechanism. YOLO V8 does not include inbuilt attention modules, so it fails to selectively focus on important features and contextual region. They also have basic loss function like CIOU, which considers only the center distance, aspect ratio, and overlap. And also it ignores the angular alignment and shape mismatch. So the motivation for enhancement is to improve the spatial awareness and feature selection using the attention module. We'll be using CBAM and FC. And also we are introducing SIOU laws to handle complex geometric relationship for predicted and ground truth boxes. So this is the enhanced architecture of YOLO V8 module, which I'm using for my research. The SE module has been integrated in the backbone, and CBAM has been integrated into the head, and SIOU loss function has been also integrated. So SE is nothing but the squeeze and excitation module. The squeeze and excitation module is designed to recalibrate the feature channels. It enables the network to focus more on informative features and focus less on unuseful ones. The squeeze is the global information embedding, which performs the global average pooling on each channel to capture the global information. An excitation model passes the squeeze vector to a bottleneck two-layer fully connected layer like a rail and sigmoid. CBAM is nothing but the convolution block attention module. It is an attention module that helps a network focus on where and what to look in the feature maps. It combines the channel attention and the global attention in a lightweight and effective way. The channel attention helps prioritize the relevant features, whereas spatial attention guides the model to focus on object regions and more accurately. So the SIU loss function is a bounding box regression loss designed to provide better geometric alignment between the predicted and the ground truth boxes. It focuses on distance between the box centers and aspect ratio matching. It also focuses by considering the angle cost, distance cost, and shape cost. The data set which I'm using is the customized data set, which is called as CSOD_24. That is the construction site object detection data set, which has been customized for this research purpose. So this data set consists of a total of 100 videos, each of 10 seconds. The FPS used is of 10. So the total number of video frames which have been extracted from these videos is 10,000. The size of the video frames which are maintained is 640 by 480. The number of classes which I'm using for this object detection is 4. Labeling is done in 3 formats, that is .text and .json and .xml. So these are the implementation details. I have used the Google Colab Pro for implementation purpose. Extremely sorry, my presentation mode is not working, so I have to go in this way. These are the experimental results which have been used by using enhanced YOLO V8, which integrates the SC, CBAM and SIU module. So here we can see the the ratings of this. And if I compare with this, the standard YOLO V8, the enhanced YOLO V8 will be are having the much better results. These are some of the glimpses of the objects which have been detected. The next part of my research is safety monitoring at construction site using detected and classified objects on CSOD dataset. Here, the safety monitoring is done by considering the proximity detection between the workers and the excavator. So here the ZODEPT is used as a proximity detection algorithm. ZODEPT is a molecular depth estimation model developed by Intel Labs, which combines the strength of binocular and monocular vision. It is trained with loss functions that combines the relative depth loss, scale invariant loss, and photometric reconstruction loss. So these are the safety considerations which have been used for my research purpose. For this is a video frame which consists only the worker without helmet, and he is also having the safe distance to the excavator. So in this case, when I have applied the proximity detection algorithm, it is giving the helmet violation. So the helmet violation is given only when the worker is without helmet and is also having the safe distance. Now here the distance I have kept the threshold distance which I have maintained is here 8 meters. So it is above the threshold. So it is at the safer distance. So here only the helmet violation has been done. So it is giving this message. In the next case, this is here also you can see that here also is the worker without helmet and there is no excavator in the surrounding. So in this case also we can see that helmet violation has been done. Worker is without helmet is detected and the distance to excavator is not applicable because no excavator has been detected here. In the next safety consideration, I have used the proximity violation. Here, worker with helmet is there, but is very close to the excavator. In this case, it will give the proximity violation. Your worker is with helmet. He is using one safety rule, but he is very close to the excavator. That's why it is giving proximity violation.
Excuse me, ma'am. Just
Yes.
to give you a gentle reminder that 9 minutes are up for the present.
Yes. Okay, sir. Thank you. The next is severe violation. Your worker is without helmet and is also very close to the excavator. So he is violating the two basic considerations. That is, worker is without helmet and also is very close to the excavator. So it's a severe violation. In another scenario, we can see that the workers all are wearing helmet and there are no excavator. So in this case, it's a safe scenario. Here also, only excavators are seen in the video frames with no workers in the surrounding. So you can see that it is also a safe scenario. Again here, workers with helmet, but is maintaining a safe distance to excavator. So here, both the safety rules are followed. So it again is a safe scenario. So the conclusion and future work, the enhanced YOLO V8 with SC, CBAM and SIU laws improves the accuracy and localization for construction site safety monitoring. The integration of molecular depth estimation enables identification of helmet and proximity violation in real-time scenario. Future work will explore multi-camera and temporal analysis to complex worker equipment interaction. These are some references. Thank you.
So do you
Any
have any
questions?
questions for the presenter? I would like the next author, Uvesh Sipai, for the paper title Exploring the Impact of Tinkercad on Higher Cognitive Learning Outcomes in Electrical Engineering. So do we have you?
Good afternoon. Yes,
Yeah.
I'm
You
available.
can start your screen.
Okay, thank you. Just give me a moment. Is my screen visible?
Yes.
Yeah, thank you. Okay. Good afternoon, everyone. I'm Professor Wesipai. I am presenting on behalf of my co-authors, Vatsal Kumar Patel, Nishan Kotari, Tapan Kumar Trivedi, and Madhu Sukla. Paper title Exploring the Impact of Tinkercad on Higher Cognitive Learning Outcomes in Electrical Engineering. This is the outline of my presentation. I will briefly go through the introduction, literature review, then methodology, implementation, result, discussion, and conclusion. Uh, Teaching complex subjects like transducers, sensors in electrical and mechanical engineering domain, it is a little bit difficult. The traditional teaching pedagogy, which includes the theoretical lectures, the reference material like a textbooks, are mostly not suitable, and it is insufficient for better deep understanding of engineering concepts like sensors and transducers. And there are also a limitation in tier 2 institutions in India, okay, which often have a limited laboratory infrastructures. So the gap exists there between the theoretical knowledge and practical application and understanding of real life application of these technologies. So our objective is to work with some virtual tool like Tinkercad that we have presented here, okay, that can specifically enhance the higher order thinking skill for a particular domain in engineering. So there are many studies that are already had done based on the virtual laboratories. So actually, virtual laboratory allow the students to perform the experiments, the play with the various tools and devices virtually, okay, without restriction, without getting worried about the safety and all those things. So there are tools like MATLAB PS kits are very well adopted in introducing the complex system and complex topics to undergraduates. But there are still some limitations are there. These tools are require a very you can say heavy processing powers, and that needs powerful computers. Here, why Tinkercad? Actually, Tinkercad is a web-based app, okay, which allows the virtual circuit design and play with the various sensors, microcontrollers, so which enables the students to work with their mobile devices also. So in particularly the domain of sensor and transducers, this Tinkercad has been introduced for various other domains also, but here particularly for teaching topics like sensor and transducers, okay, specifically teaching a sensor and transducer requires the knowledge on, we need to depart the knowledge of calibration process. So that is actually a difficult to cover it up in a theoretical session. So for that, we are going with this Tinkercad. So in this particular case study, we have a sample size of 27 students who are studying in third semester of electrical engineering. We have a diversified participant, 22% female students and 77.8% of male students. Here we are also considering lateral students also. Out of total 29% students are from lateral entry, means they have already done their diploma engineering. If we see global diversity country-wise, okay, we have a mixture of students here. So we have students from India, majority of the students, 48% students from India, and 51.9% international students are incorporated in this study. These students are from the countries like Zambia, Zimbabwe, Sudan, South Sudan. So actually, this mix, or we can say a diversity, offer the insight into how Tinkercad impacts the education across the varied background and various learning histories. So here is our experimental design. First of all, we have introduced a particular topic, theoretical topic in a traditional way. Then we have done a pre-assessment. So we have conducted a test, okay, that is designed to evaluate the student at a various cognitive domains. And then after that, we have introduced a Tinkercad. The instructor have given the instructions how to do it and demonstrated it. Then the few tasks has been given to the students through a Tinkercad platform. So where students have done a hands-on learning, okay, they have played with these Tinkercad tools and completed the assigned task. Then we have done a post assessment. Okay, so this post assessment is quietly in line with the pre-assessment. Again, the questions are ranging from various cognitive domains, okay, in the Bloom taxonomy level. And at the end of the entire this case study, we have conducted the feedback on usability and engagement of this Tinkercad tool. So here are the few screenshots that these Tinkercad tools allow the creation of classroom, assigning an activity. The instructor can see the submission by each student and evaluate it digitally also. So here is the distribution of various questions along the various Bloom taxonomy levels. We have considered 20 questions in pre as well as post assessment, which include 1 mark questions, which is mixture of MCQ, true, false, fill in the blanks, and short answers. And we are using this consistency, means the post assessment questions are also in the same pattern. Here are the results that we have obtained in the pre-assessment. You can see on this chart, we have a distribution for the pre-assessment and post-assessment. 0 to 5 marks, we can see that in pre-assessment, there are 3 students who have scored 0 to 5 marks. And we can see that 15 to 20 marks, there are 5 students are there. But if we see the post-assessment, so we can see here the 0 to 5 marks range. Okay, out 3 students were there. Now it is reduced to 1 only, and we can see a very huge improvement here. Okay, from 15 to 20 marks range. Okay, there were 5 students previously. Now in post assessment there are 12 students. We have also conducted the statistical test here. Okay, so paired t test where we have obtained t equal to 3.52 and p equal to 0.024. Okay, so this actually indicates statistical improvement in the student performance from P to a post assessment after introducing of Tinkercad. So here we can see the results of cumulative marks for different cognitive domains in a Bloom taxonomy level. So we can see that remember to evaluate level. And if we see the pre-assessment, post-assessment score and the percentage improvement that we have seen, we can see that at the higher cognitive level, okay, the percentage improvement is really good. So actually here, Tinkercad is helping the student to understand the mostly the concept related to apply, analyze, and evaluate level. After that, we have conducted the feedback on the engagement and usability. So majority of the students they are agreed to they are agreed that they are using these Tinkercad tools for gaining the skills to increase the in-depth understanding of particular topic. And a majority of the students found that it is very easy to learn and very easy to use tool. Okay, that can be operated with the help of mobile device also. And we have also conducted the feedback in the form of users frequency, where out of this total sample size of 27 students, so it is found that more than 70% students are using it 1 to 2 times a week. Okay, so that is really a good number. So here is the conclusion. Based on this case study, we came to know that introducing a Tinkercad, particularly in the subjects like sensor transducer and explaining their calibration process, a 1 to 2 hours exercise on Tinkercad really improved the student understanding, particularly in higher cognitive domains. The recommendation is like if we can introduce such tools where student can play with the various you can say a sensor technology, then it really help them to understand the topics in a better way. The future scope is actually we should investigate the long-term retention of these learning gains, because majority of the students, we have done this study for 6 months, but majority of the students we have found that they have stopped, maybe they stop using this tool, okay, for future use. Okay, so how student can keep using this tool for a longer duration, and also such tools can be also used for other engineering concepts, okay, and to increase the understanding of the students. Okay, so these are the future scope. Here are the references, and yeah, thank you. Any questions?
Sir, if you have any questions for the presenter.
No question.
Okay. Thank you.
You can stop scanning. Now I would like to call the next author, which is Ritik Patra, and the paper title is Multimodal Deepfake Detection, Integrating Video-Based Analysis, Explainable AI, and Forensic Techniques.
Good afternoon, everyone.
You can start your
Am I
screen.
audible? Yeah.
Yeah, you're audible.
Is my screen visible?
Yes, sir, it's visible.
Wait 1 minute. Yeah, is it visible now? Hello.
Yes, sir, it's visible.
So, good afternoon, respected chair, judges, and my fellow participants. Thank you for the opportunity to present our work at ICTCS 2025. Today, I, Ritik Kumar Patra, on behalf of my co-authors, J.S. Dixon and Nirvan Dalai, Shubham Singh and Parth Dwivedi from Dayananda Sagar University, Bangalore. I'll be presenting my paper ID 657 titled Multimodal Defect Detection Integrating Video-Based Analysis, Explainable AI and Forensic Technique. So let us begin. So the abstract part. So here our work introduces a multimodal detection pipeline that combines visual analysis using efficient net explainable AI through GradCam heat maps and digital forensic techniques such as compression artifact analysis, which also includes noise analysis and metadata anomaly detection and watermark tampering checks. This approach not only achieves strong accuracy and robustness, but also provides clear visual explanations of how decisions are made. We believe this framework adds a resilient and transparent layer to defect detection and digital forensics. So coming to the problem statement or the challenges that already exists in the domain is the deepfakes are AI generated videos that realistically mimic human faces, expression, live movements, and even voices. They are increasingly be used to spread misinformation, commit financial fraud, and damage reputations. Most existing detection models depend on audio information and also video based analysis who solely depend on CNN models like ResNet and Mesonet, making them ineffective for video only content. Additionally, they often overlook forensic markers like compression artifacts, metadata inconsistency, or even watermark tampering. So finally, current models are vulnerable to adversarial techniques, deepfakes, physically crafted to full detectors. Now, these gaps motivated our research. So the research gap and what is a solution that we propose. From the literature study that we conducted, two critical limitations stand out. The first one is limited integration of forensic analysis. Most models focus only on deep learning classification and ignore the subtle forensic clues. Second, high susceptibility to adversarial manipulation. The research gap is clear. We need a holistic system that combines AI, digital forensics, and explainable AI specifically for the video only data. So, our solution addresses this through a multimodal framework integrating deep learning and forensic analysis for a better resilience, incorporation of GradCam for transparent visual explanations, and focused forensic feature extraction on compression artifacts, metadata inconsistency, and watermark tampering. So the key contributions are the first, a holistic system that seamlessly integrates video-based deep learning, digital forensic, and explainable AI. Second, a multimodal pipeline that significantly improves robustness and reliability in detecting tampering. Third, visual explanation using GradCam heat maps, DCT heat maps, allowing both users and forensic investigators to understand and trust the model's decision-making process. This makes our approach particularly valuable for real world forensic and security applications. So coming to the system architecture that we have devised is it is a first the front end will be there, where we'll create a front end site where people will be able to upload the videos. Then there will be back end. Then in that there will be two thing that will mainly be working in the back end. That is first the deep learning model, that is efficient net, and then the forensic parameters. So both will be running in a coherent manner. Then one output will be generated, that is what we call the deepfake score. And upon the deepfake score, which will be decided, and then the overall architecture will tell us that if the particular image or the video is a deepfake or not. So in the deep learning part, if I explain the parallel this components parallelly, then the deep learning is what efficient net CNN performs frame level classification to detect the visual inconsistencies. Then the forensics, which analyzes the metadata, compression artifacts, the watermark tampering as independent evidence. And then the explainability, that is GradCam generates the heat maps that reveal which regions of the frame influence the model's prediction. All three streams contribute to the final decision, creating a multi-layered defense. Now, moving on to the related work, deepfake detection has evolved from manual feature engineering to powerful convolutional neural networks like Exception, Efficient Net, and ResNet, which detect spatial and temporal irregularities effectively. However, these models remain vulnerable to compression and adversarial attacks and often lack forensic integrations. Explainable AI in deepfake detection is still underexplored, with most models remaining black box. Black box, we mean the opaqueness of the AI, if it is not able to verify the result that it is showing. So yeah, making them less suitable for legal or forensic use. Our work bridges these gaps by combining GradCam based explainability with robust forensic checks. Now I'd like to explain the methodology that we have taken into consideration to solve that particular gap that we devised. So yes. So our approach is designed for video only detection using the self-DF dataset. We begin with frame extraction and pre-processing. Frames are resized to 320 cross 320 pixels, normalized and then augmented with horizontal flips and brightness adjustment to improve generalization. Then for classification, we use EfficientNet B0 with transfer learning from ImageNet fine-tuned on self-DF. It excels at detecting fine-grained visual artifacts such as facial distortions and inconsistencies. On the forensic side, deepfakes often undergo multiple encodings, leaving unusual compression patterns. We apply discrete cosine transform to image blocks and measure high frequency components. A higher compression score indicates likely double compression and a strong sign of manipulation. Now, the forensic part that we have chosen comprises of mainly three things. That is the compression artifact, the noise data, noise and the metadata and the watermark tempering. Here I have explained the compression artifact. Then moving to the second part of the methodology, the noise residual analysis. Here, with here we perform noise residual analysis. By subtracting a blurred version of the frame, we reveal inconsistent noise pattern typical to synthetic editing. For metadata anomaly detection, real videos have consistent attributes like frame rate, encoder, and creation time. Using FFPro or EXIF tool, we check for odd frame rates, missing timestamps, or inconsistent encoders. Any anomaly raises the forgery likelihood. And after that, the watermark anomaly detection, we use frequency modeling in which we check if the original video has some watermarks or not, and based on this we check if there is any incoherence with the watermark on other frames of the video. Then here the matrix calculation we have provided, where the raw model probability will be there. Then it will be adjusted based on the bias. Then we'll normalize the score, and then we'll combine the forensic score along with the defect probability that is generated by the deep learning model, and we will give out a result that is known as, that we call the defect score. And based on that, we will predict if the particular thing is fake, or if the particular thing is fake, or it is a real image or a real video. So which will also increase the accuracy of detection, and will decrease the false positives and the false negatives too.
Excuse me, sir. This is just a gentle reminder that 9 minutes are up.
Yes. The results. We also visualize compression artifacts using density heat maps. As you can see, fake frames often show blocky patterns with sharp boundaries and a hallmark of double compression. In contrast, real videos typically display more indicating consistent single compression. Then moving to the GradCam result here, it highlights the part of the frame for which the model predicts that the particular frame of the video is manipulated. We implemented it in a prototype model, and this was the results that we got. The dataset was self-DF, the metrics, the accuracy was 79.78, the precision and recall was 0.5 and 0.39. And then this was the UI that we developed, video-based defect detector. The analysis results from frame 50. You can choose a frame number. It showed all the incursionary resolution, machine creation time, then how the metrics are calculated and insight for it, and then finally it will show the prediction if it is a deep fake or not. Then concluding my side, I would like to tell we propose a general purpose multimodal method that combines deep learning, explainable AI, and digital forensics to create a robust multi-layer defense against synthetic media. Our system improves accuracy, transparency, and reliability, detects subtle manipulation missed by traditional CNNs, and performs strongly on challenging video-only datasets. The integration of GradCam and forensic visualization significantly enhances user and forensic understanding. For the future work, we think of extending to audiovisual datasets for full multimodal detection, optimizing for real-time processing on a higher-end hardware, incorporating adversarial training to defend against evolving deepfakes. Thank you. If any questions.
Sir, do you have any questions? Can you please stop your you can stop sharing. Yes. Now we'll like to call the next author, Asha Prabha Mohanta, and the paper title is Workflow to Develop a Comprehensive BIM-Aware Library Through Parametric Modeling.
Good afternoon, everyone. Just sharing my screen.
Yes, sure.
Is it visible?
Yes, ma'am, it is visible.
Sorry, it's not sticking. Okay. Good afternoon, everyone. I am Dr. Ashapra Mahanta, currently working as assistant professor at School of Architecture and Planning. And this paper is co-authored by Dr. Ravinarayan Mahante. Our title of this research is Workflow to Develop Comprehensive BIM-Aware Library Through Parametric Modeling. The overview of my presentation will be background and research gap, methodology adopted for this particular study, BIM-Aware library as in the examples, case-based application of this BIM library, and will be ending at discussion conclusion. So to begin with, as we know, our population has risen to be the topmost in all over world. So with that, the energy demand for urbanization, for creating more housing stock has increased, and to mitigate the heat, urban heat, also we are acquiring more and more air conditioning. So this demand energy, and to address this issue, government has implied or has steadfast the adoption of green buildings, BIM, is at most as in like mandate and everything, but still there are some kind of failure we can see in this adoption process. Mostly if you're talking about the BIM part, we are mostly relied on the global libraries, and the region specific libraries are missing in current context. So this paper mostly talks about is my screen visible?
Yes, it's visible.
It's not visible to me. So
Currently, I'm able to see the research gaps.
Just a second. Okay. Let me minimize it. It's creating.
So the paper talks about how we can create a Indian-centric BIM our library, basically based on the climate-based materials and passive features like jalis, which is very prominent in our Indian context, and how BIM can help us for creating the parametric or customizing the Revit families of these materials and passive features. So the methodology which we adopted was on two stages. First, we listed all the popular building materials as per the climatic zones. And then the second stage is to understand the BIM platform and how we can develop the BIM customized BIM our library. So, if you're talking about the climatic zones, each of the climate has its own requirement of as in material considerations. For example, if you're going for hot and dry climate, it requires high thermal mass, insulative and reflective materials. So the materials which we can adopt for those reasons can be adopted. Mud bricks, lime plaster, stone, fly ash bricks. Similarly, for each of the climatic zones, it has certain kind of characteristics which is in material considerations, and accordingly the materials are chosen. But in case of a global library, this thing is not considered. Okay, so when we're talking about now in the second stage about the BIM object classifications, so we need to know what are the different elements in the buildings which we are considering. Like if you're talking about the doors and windows, it is dependable on walls, so that comes as in family instance as an element and which is dependable. Next is your host elements like walls, floors, roofs, ceilings, which can add few things like wall openings, as in doors, windows, fenestration, jalis, which can be catering on those kind of host elements, and structural elements as in columns and beams. So the methodology which were adopted for customizing the BIM library, we start with the references. This was based on Revit platform, which is most popular among the designer groups. So step one is where we are creating the customizable BIM library, where we are considering the reference planes as in a plan, and how we are placing those kind of things. This is the example which we're considering as an accurate jali work. Step two, where we are adding additional informations like what will be the name of the thing, length, dimensions. Those all informations are given to this particular library, and any kind of restrictions are also can be added to this libraries. Further, using the 7 steps, we can create our own library, and using the 6th and 7th step of this particular methodology or workflow, we can generate instances out of this family. Again, if you want to add any kind of additional features or additional parameters to this particular library, like additional information, as in if you're talking about maintainability is something which relates to how easily we can maintain a particular element or particular building materials or component. So this kind of thing also can be added in BIM platform. As in a shared file location, which can be used by multiple users at the same time. So these are few instances which was created using the customized or the proposed workflow, the different types of plans of different walls. And these are the basic features: an overhang with 2 fins, overhangs with 1 fin, jali with hexagon shaped wards. All these are being created. So this particular library was brought into application for in one of the case study building, which was chosen as in one of the commercial building, which is situated in Kolkata in warm, humid climatic conditions. For building materials, we had chosen AAC blocks, tinted double glassed materials. This is just to demonstrate the how this proposed workflow can be used to customize the library, and we can use those materials for analyzing in the conceptual stage of the building, and we can accordingly we can predict the energy uses and we can take decisions based on those analysis. So this was one of the part of my research work which was already published. So looking forward for discussion and conclusion. So if we compare with this proposed BIM our library to the international BIM libraries, there are certain kind of parameters which we can look into, like for example, objective. Standardized BIM objective from global manufacturer for design and construction efficiency. International product or the manufacturer, they generally create those kind of BIM libraries. There are different type of platforms which we can see where we can download those kind of libraries. There be BIM Object, NBC, BIM Smith. All these are the platforms. Whereas this proposed one is focuses on the climatic zones based on ECBC 2024, local green materials like adobe, bamboo, fly ash bricks, which are very popularly used in our local conditions. Climate conditions, like for the international BIM libraries, is oriented to temperate or developed world conditions, whereas in Indian diverse climates we can find so regional specific elements can be modeled in this particular workflow. Standards are which are aligned with based on ISO 19650 IFC BSDD. These are for the international standards where we can localize it with our own BIS, Bureau of Indian Standards, ECBC 2020 and ECONIVAS 2021. ECBC 2020 is for commercial building, ECONIVAS is for residential buildings. And parametric is like where we can additionally customize our requirement, and we can develop the building we can develop the component out of it. So it can be also a open collaborative platform where different designers can come together and they can share those building components, BIM components, with the other designer group. So we can for which can lead to like more promoting the local materials in the AECO industry and to support the sustainable designs, which generally is losing its value in due course of time, but still it's getting a momentum right now. Estates and also will be helpful in accelerating the adoption in India, and also it aligns with net zero 2070 goals. So these are the differences which were used for developing this particular research. Thank you.
Thank you, ma'am.
Any questions?
So do you have any questions? Ma'am, you can stop sharing the screen.
Okay, thank you.
Yeah. I sincerely thank all the authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the 10th version of this conference, and also about the 9 previous versions. We'll be very happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publications will be live within 7 to 8 months. So kindly cooperate with the team of ICCTS. I also thank our session chair, Mr. Sachin Gupta, for chairing this session. This is a thanking note token of appreciation from the conference. Sir, any words to end the conference? I request everyone to please switch their cameras, switch their video on, because I have to click a virtual photo. Yeah, 1 second. Thank you.